Here Angie, the branch manager of Citibank, and she wants to improve the service of the bank by reducing the average waiting time of the bank's clients. She was able to determine the average arrival and the average number of clients serviced per hour. The figures are summarized in the table below, or rather in the next slide. How many clients are in the bank at any given time? How many time does a client spend in the bank? And how many clients are waiting to be served? How much time does a client spend waiting? What is the probability that the teller is busy? And what is the probability that there are no clients? So as you can see, there's a lot of questions thrown to ask on the last part of the problem, and we will going to try to answer these questions using the queuing theory model natin. Hello everyone, so we are now here on the first model of queuing theory. I hope you have already learned all about the introduction of queuing theory, which is our previous video before this one. No, so dito po aaralin na natin yung pinakaunang model natin ng queuing theory, which is the MM1. Okay? So model number 1, MM1. The MM1 notation represents first, the arrival distribution, that is the first M. And on this model MM1, the arrival is Poisson distributed. No? So, Poisson distribution ang meron tayo for the arrival. And for the second one, we have the service time distribution. So, for service time distribution, second M, that is exponential distribution. I hope by this time, since you are done with your statistics class, I hope you already know the difference between the Poisson and the exponential distribution. And for the last one, number of service channels open. So that is M equals 1. Meaning, we only have here one server. Okay, doon sa ating queuing system. Okay, so let's have our example problem regarding this model 1, the MM1. So example number 1, Citibank. So, i-apply natin guys ang queuing theory in banking industry. This is why IAs can also have their career in financial sectors, no, aside sa being quant or in speculating and forecasting the future price movements of different financial market assets. You can also be employed in banking and financial industry as the systems analyst, and part of that job, no, that is only one of those different jobs that an IE can function sa ating banking and financial industry. Pero part nun is yung application nitong queuing theory. Okay, so let's have it. Citibank. So we have here Angie, the branch manager of Citibank, and she wants to improve the service of the bank by reducing the average waiting time of the bank's clients. She was able to determine the average arrival and the average number of clients serviced per hour. The figures are summarized in the table below, or rather in the next slide. How many clients are in the bank at any given time? How many time does a client spend in the bank? And how many clients are waiting to be served? How much time does a client spend waiting? What is the probability that the teller is busy? And what is the probability that there are no clients? So as you can see, there's a lot of questions thrown to ask on the last part of the problem, and we will going to try to answer these questions using the queuing theory model natin. Okay, so here's the data table na given from our problem. So the number of tellers, this is the M guys, which is 1. This is the MM1, the 1 in the model and the notation MM1. And for the arrivals, we have here 11, and that is represented by the symbol lambda. I hope you are familiar with this symbol, no, lambda. Arrivals per hour, meaning there are 11 clients arriving at the bank per hour. This is on the average, and the mu serviced per hour, that is the mu natin. Mu stands for the average, no? 12. Meaning, in every hour, there are 12 na natatapos i-serve doon sa loob ng bank natin. Okay? So what we will going to do now is to set up the statistics table. Ito po lahat ng mga tinatanong sa ating previous slide. If you will going to read these questions again, yung nasa last part, ito rin po yan lahat na kinonvert ko lang siya into statistics table and of course their corresponding equations. So, for example, number of clients in the system that is represented by letter L, average hours client spends in the system represented by W, average clients waiting online that is L sub Q, so line sub Q, Q stands here for Q, average waiting hours per client, W sub Q. Q stands for Q. Medyo Q stands for Q. Q stands for waiting or Q stands for pila. Q. Probability that the teller is busy, that is represented by rho, and probability that there are no clients, that is represented by P sub 0. So we don't have yet our values here because that is what we're going to do to solve for the values nila, no, and have the answers for those questions stated on the problem in the last part. Okay, so let's solve now our statistics table. Let's complete this table. So for the first part, let's compute for the average number of clients in the system at any given time. So for this one, our formula here is L, that is the average number of clients in the system, equals to lambda all over the difference of mu and the lambda. Okay, as you can see guys, we have here the value of lambda 11 and the mu which is 12. So direct substitution, it will be 11 over 12 minus 11. And since this is 11, this is 12 minus 11, that is basically 1. So 11 divided by 1, we have here 11. So therefore, the average number of clients in the system at any given time, this is 11. 11 clients are in the bank on the average. So that is our first part of the statistics table. Let's have here 11. And let's have my pen muna na black tayo para masulat natin siya. No? So we have here 11. Okay, so we're done for the first one, number of clients in the system, which is equivalent to 11. Okay, now let's compute for the average number or rather average hours client spends in the system, which is the W. Gaano sila katagal no, na nasa loob ng system per client on the average. So that is the second one, average number of hours a client spends in the system. And for this one, our formula here is W equals 1 over mu minus lambda. And as you can see, we have one na numerator, then same sila ng denominator sa previous number natin, mu minus lambda. So basically, this is 12 minus 11. Therefore, we will going to have here 1 over 1. And that is equivalent, of course, to 1. Meaning to say, we have 1 hour na average time a client is inside the bank. So, using the queuing theory, you can expect, if alam mo na to before, paano, you can expect or you can lend your time amounting to 1 hour if pupunta ka doon sa bank. Alam mo na yung itatagal mo. At based sa queuing theory, ito pala, pag pupunta pala ako sa bank na to, I can spend 1 hour doon sa bank na yan based on the computations. Okay? So, I hope you get it. Let's write this on the statistics table. So, pakonti-konti na natin siyang nalalagyan ng values, no? So, 11, and now we have 1. Okay, now, since we're done with the first two, let's move on now to the average clients waiting online. Ito yung average na number ng mga kliyente na nakapila. No? Gaano kaya karami yung nakapila at specific given time. So, let's proceed with the number 3 computation here. Okay, so right, number 3 is compute for the average number of clients waiting in line, or this is L sub Q. So, for L sub Q, guys, the formula here is lambda squared all over mu multiplied to the difference of mu and the lambda. So here, we have lambda na 11. So 11 squared, ayan. Our mu is 12. So we have here 12. And 12 minus 11. So we all know that this 11 square is, sige, i-direction natin mamaya sa calculus na lang. This 12 minus 1 is 1. So 1 times 12 is 12. No? I-direction natin ito sa calculator, 11 squared divided by 12. So let's go to our calculator. Okay, so here we have 11 squared over 12. Answer is 10.0833. Okay, so let's write it here. 10.0833. Meaning to say, guys, we have 10.08 or 10 clients waiting in line on the average. No, so 10 kayo yung nakapila. That is the number 3, yung tinatanong ng number 3. And let's write this on our statistics table. That is 10.0833. Okay, so let's have it here, 10.0833. Next, we must now compute for the value of the average waiting hours per client. No, gaano kaya sila nagtatagal sa paghihintay doon sa pila, no? Okay, so let's have our pen na white na ulit. Then, number 4 tayo. Compute the average number of hours a client waits in line. Sa pila po ito. Magkaiba yun sa nauna natin na-compute the average number of hours a client spends in the system, which is yung number 2. Dahil ulitin ko po, when we say system, kasama dito yung server. No, simula pumasok sila, pagkapila, hanggang na-serve, hanggang umexit sila ng system. That is the whole system. Which is na number 4 na tinatanong, yung tagal lang nila sa pagpila. No, yung nasa pila, hindi kasama yung serving time. Okay? So, for this question number 4, our formula here is W sub Q equals to lambda over our denominator here is mu multiplied to mu minus lambda. So, almost the same, no? Huwag kayong malilito dyan. So, let's have it here, 11 divided by 12 multiplied to 12 minus 11. So, we have here 11. Since 12 minus 11 is 1, and 1 times 12 is 12. So, 11 over 12. Basically, 11 over 12 is equivalent to 0.9167. So, let's have it here, 0.9167, meaning to say, guys, we have on the average 0.92 hour average time a client is in line. No? So, more likely, almost mag-iisang oras na. Pero kung titignan ninyo, no, mas maliit lagi yung sagot for the number 4 since this is just the average number of hours a client waiting in line, while this number 2 is yung kabuuang system. So, kapag itong sagot nyo sa number 4, naging mas malaki compared sa number 2, magtaka ka na. No, there's something wrong with your formula or baka naman doon sa inyong solution. So, laging mas malaki yan si number 2, no, dahil buong system yung tinatanong niya. Okay, anyway, let's have this answer sa ating statistics table. So, isulat natin, dahil nandito yung mga summaries natin, no? 0.9167. Okay, so last two. Probability that the teller is busy. So let's have our pen. Right? So probability that the teller is busy, number 5, i-compute po natin. So for this number 5, we have here the formula for rho equals lambda over mu. Our lambda is 11 and this is over 12, the mu. O, kung titingnan natin, pareho, no? 11 over 12. So, meaning to say, that is also equals to 0.9167. 0.9167. Or, this is equivalent to, natin percentage, 92%. No? So, lagay natin sa ating statistics table, 92%. Ano po yung sinasabi ulit ng 92%, no? Ito yung probability na busy ang teller. 92% or 0. Gaya na lang natin yung decimal since naka-decimal naman lahat ito. Medyo awkward. kung maglalagay ka dyan ng percentage. Ibig pong sabihin, no, malaki yung chance na busy si teller. Ikaw ba naman on the average nga, di ba, average clients waiting online per hour, ito, 10 may nakapila. Tapos, ang number of clients in the system nila per hour is 11. Tapos, isa lang yung teller. Kung malamang, busy siya. Mataas yung rate na busy si teller. Kaya, ang naging result is 92%. So, for the last one, probability that there are no client. Gaano kataas yung probability na wala tayong client considering the data na binigay sa atin. That is number 6. No? So, let's compute for the probability that there are no clients. So, dito guys, this is basically P sub 0 equals to 1 minus lambda over mu. Ito lang po yan, no? Lambda over mu. Minus lang natin from 100. Dahil nga, this row is probability na busy siya. So, dito, probability na wala naman tayong kliyente. Now, there are no clients in the bank. So, 1 minus lambda over mu. This is equivalent to 1 minus 11 over 12. So, 1 minus 11 over 12. Let's have it here. 1 minus 11 over 12. That is equivalent to 0.0833. So, let's have it here. 0.0833, or basically, this is equals to 8.33%. Ito kung gusto nyo lagyan ng decimal, no? 91.67%. Round off ko lang siya. 0.0833. Let's write it here on our last part of the statistics table. 0.0833. So, ito naman, yung probability na wala tayo client. Kung titignan ninyo, no, napakaliit na probability na wala tayong client. Kasi nga, no, mataas yung probability on the other side na BCC teller. Kasi isa lang. No, why not? Guys, itong simulation na part dyan. Why not dadagdagan ko ang aking tellers waiting dalawa? Ano kaya yung pwedeng mangyari? No, and if that is the case, you try the data kung mas magiging maganda kaya yung result, mas kukunti kaya yung clients waiting in line, yung tagal nila sa buong system, etc. and etc. So that is the first problem natin, no, regarding this MM1 model. So for the example number 2, let's have now Citibank pa din, kadugtong po ito. So Angie, the branch manager of Citibank, knows that there is also an opportunity cost for clients who are idle while waiting in line. Nasayang kasi yung oras nila, no? So, yun ang nasabi ko, on a business perspective, waiting is actually a waste. Nasayang siya, meron niyang kaakibat na oras, and oras is actually, time is money, di ba? Lagi sinasabi. Waiting in line. She was able to determine the teller's labor cost as well as the average opportunity cost of clients who are waiting. So, given yung data ng opportunity cost ng client and yung sahod ng teller, what we're going to do now is to have an answer on this question, which is how much is the total cost per shift? Magkano yung gastos nila per shift? So, let's try to compute it. No, ito yung data na binigay. Service cost per teller. This is actually the labor cost of teller. No, $5 per hour po. And that is represented by the symbol C sub S, or the cost sub service. So, cost of waiting, dollar per hour. That is $6 per hour. Represented by the symbol C sub W. So, C is cost, W is waiting. So, cost of waiting. Working hours per shift, basically that is 8 hours. So, we need to have this cost table, no, per hour, and if we wanted to convert that per shift, no, times 8 lang naman ang gagawin natin. Dahil nagbigay siya dito ng values per shift, no, 8 hours per shift. Same lang yan. No, pero ang end goal pa rin natin is of course masagot yung tanong na how much is the total cost per shift, no, total cost. That's why ito yung kailangan natin punan mamaya, yung value for the total cost. Okay, I hope you get it. Now, let's have the answers for the cost table. For the first one, let's compute first for the total service cost, or the T sub S. So, here, the total service cost natin per hour yan, yung computation natin, ang formula natin dyan is equivalent to M multiplied to C sub S. What is M? Ulitin ko po, no? M, ito yung servers natin. Na unang part, balikan ninyo yung unang part ng presentation. Sinabi ko doon na M is the number of server, which is in our case, that is the number of teller. Since mag-isa lang siya, so 1 yan, our value for CS is 5. So, service cost per teller, ito yung sahod niya. No? So, $5 per hour. So, let's have it here, 5. So, 1 times 5 is 5. Okay, per shift naman. If gusto natin i-convert siya per shift, that is per hour kasi, no? So, madali lang naman siya. Kung ano yung naging sagot natin dito sa taas, no, total service cost per hour, multiply lang natin yan sa 8 hours. Dahil nga, per shift is 8 hours. So, basically, that is 5 times 8 and this is equivalent to 40. So, ito yung total service cost natin per hour and per shift, 5 and 40. So, let's write these numbers sa ating cost table, 5 and 40. Ayan, meron na tayong first row, no? Napakabilis lang i-solve niya. So, next, we will now compute for the total waiting cost. Okay, so for the total waiting cost, our formula there is TW per hour muna tayo, then mamaya naman per shift. The formula dyan, guys, is lambda multiplied to WQ. Again, what is WQ? Balikan natin para maalala ninyo, no? WQ stands for the average waiting hours per client. Gaano ba sila katagal naghihintay? Kaya i-multiply natin sa ating lambda, which is yung arrivals per hour. And of course, may kadugtog pa po yung formula na yun. Now, we need to multiply that also sa ating value na C sub W. Again, C sub W is the cost of waiting. Gaano ba kagastos yung paghihintay ng mga client? No? So, ayun yung tatlong kailangan natin i-multiply. So, for our lambda, we have the arrival na 11. So, if you still remember. For the WQ, our value for that is 0.9167. So, let's have it here, 0.9167. And for the CW, given siya dito, that is equivalent to 6. Given po ito, no, cost of waiting. So, let's have it here, 6. So, 11 multiplied to 0.9167 times 6. Let's go to our calculator to solve this. So, 11 multiplied to 0.9167 multiplied to 6. That is equivalent to 60.5022. So, let's have it here, 60.5022. Meaning to say, this is the total waiting cost. And this is, guys, in dollars. Sayang. No, napakalaki nung nasayang na pera, $60 sa paghihintay lang. And that is per, isang oras to, no? So, i-convert natin itong total waiting cost per shift naman. So, basically, just like what we have done in our first part of the computation, no, yung total T sub S natin, or rather the T sub W per hour, i-multiply lang natin kung ilang oras sila, yung H natin, which is, sabi nga dito, that is 8. That is 60.5022 multiplied to 8. Let's go to our calculator, diretso na to. Multiply ulit sa 8, 484.0176. So, 484.0176. Ganyan kalaki ang nasasayang. That is the total waiting cost paghihintay dahil isang teller lang yung yung naka-open sa'yo. So, ilipat natin itong data na to, guys, 60.5022 and 484.0176 sa ating cost table. So, let's have my pen colored black naman ulit. So, per hour natin, that is 60.5022, and per shift natin, that is 484.0176. So what we need to do now is the last part of the computation, which is the total cost computation. So, total na natin. I-add lang naman yan, no? Napakadali lang. So, for the total cost per hour, our formula here will be the total service cost per hour, which is ito po, bilugan natin, plus the total waiting cost na per hour. Okay, which is ito. So, basically, that is 5 plus 60.5022. So, that is 65.5022. Okay? Total cost per hour. And for the total cost per shift naman natin, tulad ng ginawa natin doon sa per hour, that will be total service cost per shift. And of course, i-add natin ito dito sa ating total waiting cost per shift. Okay, and their values are 40 and 484.0176. So let's compute this on our calculator. Ayan, nakalagay na, no? Equals natin plus 40. Ayan, dito para continue siya. Ayun. No, we have 524.0176. So, 524.0176. So, that's it. No, that is the total cost natin ng paghintay. Isulat natin sa ating cost table 65.5022 and 524.0176. So, click natin ang ating pen sa kulay black. Okay? So, let's have it here. 65. Pero actually, guys, no, if ayaw nyo i-compute ng detail, pwede nyo diretso to add nyo lang yan pa lang. Same lang naman yan. 65.50, 22, and here we have 524.0176. That is our cost table. Okay? So, for our conclusion on these two problems na binigay ko sa inyo, using the Citibank as our example, while total service cost is only $40 per shift, Angie should expect a much larger total cost of 524 because of the opportunity loss of 484. No, sayang. Ayun yung relationship niya. And I hope you get it, guys. And sana na-appreciate nyo ngayon yung tawag dito, na-appreciate nyo sana ngayon yung value of having the Turing theory. Now, paglalaroan nyo lang yun naman yung numbers, you can have different numbers dyan, palitan nyo yung lambda, palitan nyo yung makikita nyo, nagbabago-bago yung data. Okay, so for our next presentation, we will going to apply this Model 1, MM1, on the QMQM software para meron tayong graph na makikita ninyo yung galaw ng mga. Okay, so that is our first model of the Turing theory. I hope you learned something from this presentation. Keep safe always, enjoy the rest of the day, and of course the rest of the week. Goodbye.